Hello, this is Gagandeep, and today we're going to look at a data mining exercise involving a banking dataset classification. Here we have a Portuguese bank that is seeing a decline in revenue, and they have investigated why this decline happened, and they found out that the root cause was their customers are not investing enough in long-term deposits. So the bank would like to run a target marketing campaign and identify those customers that have a higher chance of subscribing to a long-term deposit. So we have 32,000 records, out of which we have 29,000 of customers that do not, subscribe, that have not subscribed to a long-term deposit, and 1,200 of them that have subscribed to a long-term deposit. So this is a class imbalance problem, and we need to keep that in mind when we're building a model. So we have 13 columns, 32,000 rows. Let me quickly jump into SAS Miner and look at how the flows are configured. So there are two flows that I've configured. So the first one determines which model to pick. Um, so we did a data partition 66, 15, 19. I'll come back to this part later. So the control point, we have three models. So this maximal decision tree has been built interactively by splitting each node so that we get the deepest tree possible. This I did it deliberately to compare it with the prune tree. The prone tree, we have the assessment measure to be misclassification. So the tree with the lowest misclassification rate on the validation set is chosen. Similarly, the neural net is also during training, the lowest misclassification rate node is picked. So we have three models. We expect overfitting here because this is the deepest tree, and we are not looking at accuracy of the model. So let me quickly pull up the results and see how these three models stack up. So the parameter or metric that I want to evaluate these models is of course misclassification rate, but the main one is the lift curve. So the lift curve captures the percent of prospects that can be, you know um, captured by the model with with the least number of list penetration. So if you look at these, the misclassification rate is quite similar to all these three models, tree 2 being the decision tree, neural net, and tree being the maximal decision tree. So we're going to avoid this maximal decision tree even though we are using it to compare it with how the decision tree is doing. So if we look at the lift value on the test set, we got 4.86 for our decision tree. So the best lift is on our decision tree. So we're gonna continue using this and further look into how we can do uh, you know um, predictions. So there are still a couple of more problems that we need to look at. One is to take business considerations into the model while predicting a class, and also make sure that we address this imbalance issue in the target variable. So for the first part where we need to take business decisions into consideration, uh, on the bank data, I have configured this to take those decisions into picture. So if we happen to know the distribution of the target variable on the population data, we could assign prior probabilities and adjust them here. So right now 88% are no's, 11.27% are yeses. So I'm going to just leave it like this for now. If we happen to know the populations, we can of course change these values. So the interesting part lies here. We have decisions. So let's say we have a couple of decisions named decision 1 and 2, decision 1 for yes, decision 2 for no. Let's say there is a cost associated with each of the customer being mailed. Let's say it's 50 cents, and we are and let's say we get an average net profit from each customer if he responds to subscribing to the long term subscribing to the program. uh, then we have, let's say, $15 profit on that customer. So these weights can be adjusted here under decision tree where we are maximizing the profit. uh, so let's say if we have decision one that says mail an individual, and if he responds we get a 14.5 uh, you know net profit, removing the costs. So if he doesn't respond, we lose out on 50 cents. So if you do not mail uh, a customer, you neither incur a profit nor a loss. So yeah, these two values are for that, and we click OK. So this takes care of the business parameters into consideration. These can be consulted and adjusted from a subject matter expert. So again, the class imbalance is So I did it in two different ways. One where I took the proportions. So coming back to this node, if we just do a simple sample from a data set, we get what is called a stratified sample, that it carry forwards the proportion of the imbalanced variable, the zeros. So here we get 88% of zeros, 11% of ones, even in a sample. So we can either oversample or undersample the minority class, or decrease the number of majority class. That can be done. So in SASE minor, we have these two options, where on the options here we have criteria. If it is equal, then it does what is called equal balancing of the classes. Then there's another criteria called level based, where we can specify the level of interest contained in the sample. 60% here, I just made sure that we have 60% of ones and 40% of zeros. So once I run the model on these two, we can see how the results are. There we go. So for T3, which is the oversampled one, if we look at the lift curve and look at the lift on, let's see the profit, how it comes up on the test set. So on the test set, if we see the total profit on Y, for T3 we have 2112, T3 being our oversampled minority class decision tree. So in this way, we can come up with a better model based on the business objective. And what further can be done is we can take an ensemble model and apply the same business parameters to that ensemble model, and we can further optimize on how we predict. Thank you.